Malaysia appears as a unified nation on maps, but its geography tells a different story.
On the west coast, economic hubs like Kuala Lumpur and Port Klang drive the nation's industry.
This region is the engine of Malaysia, handling the bulk of the country's manufacturing and trade.
The Klang Valley alone generates over 30% of Malaysia's total economic output.
Moving to the east coast, the economic landscape changes significantly, with less infrastructure and industry. States like Kelantan and Terengganu have historically struggled with slower development and weaker national connectivity.
These regions have long lagged behind in industrial output and logistics compared to the West.
Moving goods from east to west is difficult, requiring long detours through challenging mountain roads. These roads were never designed for the heavy freight volumes required by modern industry. This adds significant time and cost to logistics, ultimately limiting economic growth for the region.
To solve this, Malaysia planned a $16 billion railway cutting across the entire country.
The project spans 660 kilometers, connecting the west coast directly to the east. China is providing essential support for this massive infrastructure project.
But how can a railway fix a problem that has persisted for decades?
The East Coast Rail Link, or ECRL, is designed to be a vital economic corridor. It connects the major economic hub on the west to the less developed East Coast.
The route begins near Port Klang, Malaysia's largest port, handling millions of containers annually.
From there, the line moves inland, traversing the central mountain range towards the east. It reaches Kuantan on the east coast, eventually extending north to Kota Baru near the Thai border.
This is not a conventional railway. It is built to modern, high-speed standards.
The track width is 1,435 millimeters, allowing for higher speeds and heavier loads.
This standard allows for safer, more stable operations compared to the older meter gauge network. Passenger trains are expected to reach speeds of up to 160 kilometers per hour. Meanwhile, freight trains will carry massive volumes of cargo across the country, boosting trade efficiency.
The project includes over 20 stations, ranging from major hubs to smaller regional stops.
Multiple cargo terminals are being built to connect industries directly to the new rail network. This will significantly reduce the need for long truck journeys, making the entire system more efficient.
On paper, the route looks simple, but the construction reality is much more complex.
The Central Mountain Range presents significant challenges for engineers and construction teams.
It is a continuous mountain backbone, covered in dense tropical rainforest and steep, unstable slopes. Heavy rainfall throughout the year makes construction even more difficult and requires specialized engineering.
Engineers cannot rely on ground-level tracks. They must cut through mountains and build many tunnels. The project includes over 40 tunnels and many bridges to navigate this challenging terrain. These structures require advanced construction methods, including giant tunnel boring machines. Roughly 30 to 40% of the route involves bridges and elevated structures. These elevated structures keep the track stable, even during extreme weather conditions.
Malaysia receives heavy annual rainfall, creating risks like flooding and soil movement.
Engineers must design robust drainage systems and retaining walls to handle these conditions. Much of the route passes through remote areas with limited existing infrastructure. Temporary roads and worker camps must be built just to move equipment into place. Why bring in China to do it, and what is their role in this project? The main contractor is China Communications Construction, one of the largest construction firms globally. This is the same company involved in large-scale infrastructure projects across Asia and Africa. They are key players in the Belt and Road Initiative, financing and building global infrastructure.
A significant portion of funding comes from Chinese-backed loans, primarily through the Export-Import Bank of China.
This bank has financed multiple large-scale infrastructure projects globally, showing their commitment to such ventures.
It is a joint setup where China provides both construction capability and a large share of funding. Malaysia has been trying to improve connectivity between its coasts for decades. China's involvement made it possible to move forward with a project of this scale.
But this kind of arrangement raises obvious questions about debt, control, and long-term impact.
Before construction could fully move forward, the entire project was paused and then renegotiated.
The original cost was estimated at around 6.5 billion Malaysian ringgit. For a country the size of Malaysia, that is a major financial commitment.
In 2018, a new government came to power and reviewed large infrastructure projects.
The concern was simple. Was this project too expensive for what it delivers?
There were questions about financing terms, total debt, and expected economic returns.
Construction was suspended, but instead of canceling it completely, Malaysia chose a different approach.
The government went back to the contractor and reworked the terms of the project.
The concern was simple. Was this project too expensive for what it delivers?
This was a reduction of roughly 1/3 of the original cost.
Parts of the route were adjusted to improve efficiency and reduce construction complexity.
After that, construction resumed in 2019.
This phase highlights something important about megaprojects. They depend on politics and financing. They also rely on long-term economic expectations.
As of 2026, construction is active across multiple sections of the route.
Major civil works are already well underway. One of the most critical parts of the project is the tunnel network.
These tunnels take the longest to complete because they involve continuous excavation and stabilization.
Progress here is steady, but it moves at a controlled pace due to safety and geological conditions.
In other sections where the terrain is less complex, construction is moving faster.
You have visible structures already taking shape, including bridge spans and station foundations.
The workforce is a mix of local Malaysian workers and Chinese engineers and specialists.
When you are building over 600 kilometers of railway, working on multiple fronts is the only way.
The current target for completion is around 2026 to 2027.
There is the possibility of phased openings for certain sections before the entire line is operational.
To understand where the ECRL fits in globally, you have to look at the Strait of Malacca.
Every year, more than 90,000 vessels pass through this narrow stretch of water. They carry oil, raw materials, and manufactured goods between Asia, the Middle East, and Europe.
Malaysia's west coast sits directly on this route, which is why ports like Port Klang became so dominant.
But here is where the ECRL changes the equation.
Instead of relying entirely on sea routes, Malaysia can move part of that cargo across land.
This can be faster than a ship going around the peninsula, which can take several extra hours.
It is important to be clear. This railway is not replacing the Strait of Malacca. The volume of global shipping is far too large for that. Moving goods by sea will always be cheaper.
The advantage comes in specific cases: time-sensitive cargo and regional trade within Southeast Asia.
It also gives Malaysia more flexibility.
But the bigger question goes beyond Malaysia.
What does it mean when projects of this scale are built with strong Chinese financing and construction?
Is this simply the fastest way for countries to build infrastructure they have needed for decades?
Or does it slowly shift influence over key transport networks in the region?
And if this model works in Malaysia, how many more countries will follow the same path?
Because this is not the only railway China is involved in, and it won't be the last.
Let us know your thoughts in the comments below.